So while you dream about the nice Goan fish, coming up during the lunch, and I can vouch for that, being from Goa. So let me just start ahead with what we are going to start out here. As a storage guy, I think it's my job to frighten you of the humongous storage growth which we are seeing. But that's a fact, One of my customers in the manufacturing space is today not worried about how is he going to handle his SAP. He's more worried about what is RFID going to do to his environment. One of my customers in the pharma space is not worried about his mailing. He is more worried about what is he going to do with CCTV. And as we call it, this is something called the Internet of Things. These are basically machines talking to machines. Like Anil spoke in the morning from the Vodafone example, a POS system talking to a machine, right? For example, you would have smart electric meters which would ping your existing electric meters in your house every 15 minutes, right? And that's the kind of data growth you see when machines talk to machines, right? It's not about a simple storage administrator giving a lot of commands. So that is what we call as Internet of Things. These are machines talking to machines. And when you put in analytics, etc., there is a huge amount of data growth and data which you have to handle. So what are the three challenges which I think you all experience in your environment? Of course, I spoke about exploration of data. I spoke about an inflexible IT structure and an escalating IT complexity. I have a nice example out here. One of my customers was trying to consolidate his server environment. And he went back to each of his business users and asked them, tell me which servers you don't want to use. He spent about 20 odd days, but all the servers turned out to be critical. So what he did at the end of the week was he went quietly and he used to shut off every week 2-3 servers. If nobody came back and asked him, he assumed it's fine. So that's to add escalating IT complexity, right? But all these are proof points and all these are facts. So what is that we at IBM are doing about this? I think there are 3 governing principles which we have outlined our entire storage strategy on. One is efficient by designing. This simply means stop storing so much of data, right? This is about providing you with the required tools and capabilities which help you manage capacity as well as cost. Next we have is something called self-optimizing. The easiest example I can relate this to is a manual car vis-a-vis an automatic car. You don't want to manually interfere into your devices and see how is that they are working. The device or the storage in this case should be smart enough to understand the data pattern it's receiving and adjust itself according to that. So that's the vision we have set in terms for ourselves, in terms of building up a self-optimized storage architecture. And lastly is cloud agile, right? This is about use what's there on the floor. You don't have to go and refresh stuff, buy more stuff. Use what is there existing in your data center. How is that you use technologies like virtualization and use what is there already, what you have in your data center. This is about providing you complementary sets, complementary capabilities on your overall storage architecture. So let me take a step back out here. In the past 10 years, we have seen CPU speed increase by about 10x. We have seen RAM speeds increase by about 9x. We've seen network speeds increase. The speeds which we have not seen increase is the disk speed of the storage, right? The storage is the most fragile, I can say fragile device in your data center today. All you have seen is 7K, 10K, and 15K, and neither are we seeing any 25K RPM, right? So what does this do for you? Storage being the slowest device in your data center is making your server wait, is making your application wait, is making your user wait, is making your business wait. And that is the implication of being the slowest device in your data center amongst your network and your server. So you might say, okay, latency is not much of a problem for me, but as research shows, latency has a cost associated with it. The financial segment estimates about close to $100 million in only 1 millisecond response could save up to $100 million in a year. Amazon pegs it at about $4.8 million saved for every millisecond response which is there, right? Which we are seeing in the industry today. So with that, I am pleased to introduce to you the IBM Flash system. This is nothing but, you all have used it on the personal computing side. Most of your smartphones have flash devices. Most of your desktop laptops have flash hard disks, right? And this is what we have done, is got it an enterprise capability, right? So this is nothing but a set of flash disks made ready for your data center. First thing about is extreme performance. It can deliver up to 1.3 million IOPS, that's 13 lakh IOPS in a single 4U rack, right? Micro latency. The discussion today is no more about millisecond responses, it's about microsecond responses. And that's what we deliver with flash. Third is it's ruggedized for an enterprise capability too, right? And that's what we have done with the launch of our IBM Flash system. What I'm trying to give you out here is just a proof point of what we have done in our labs. What we simulated was about 1.3 million IOPS in an environment. What you would have typically done, using the traditional disk storage system, would have gone with about 5,000 spindles. Okay? Vis-a-vis that, to simulate the same performance with a flash storage, we were able to do it in about 1 U of rack space, same amount of performance. So what it has saved you? It has saved you 18 rack space, right? It has saved you about 76 kilowatts of power compared to 1.4 kilowatt, what you would get in a single 4U device. And I think the best thing what I spoke about was the discussion moving to IOPS per dollar, right? You would think that flash is costly, but here you can see that flash is just about $1 per IO. You compare this with a standard storage which we currently use out there, it goes to about $14 per IO. And that's the shift which we are talking about when you're looking at micro latencies, when you're looking at real high performance. So where does this exactly fit? This fits in any of your database environments, any of your batch processing environments, your VMware, VDI environments. This is another simple test scenario we had done in an Oracle 4-node case, where for about 2 million queries, which in a standard storage system took about 12.5 minutes, in a flash scenario, we were able to just do the same amount of 2 million queries in just about 1.3 minutes. A total 9x reduction just using flash. What we have again put out for you is a simple Oracle AWR report which shows you the difference in terms of a disk which is at about 13 millisecond per read and flash system which is at about 1 millisecond per read. So what I'm fundamentally driving to is it provides you 3 things. One is extreme performance, second is micro latency, and third is it's ruggedized for your data center environments. You can just take an example here. You can scale up to 1 petabyte in a single 1-floor U tile. And this can deliver up to 22 million IOPS, right? The proof of the pudding is in eating it. So we have some customer references for you out here. This is the 3rd largest telecom provider, Sprint in US, catering to about 55 million odd customers. They used our virtualization framework and IBM Flash framework. And what it resulted was in a straight business benefit where they were able to activate devices 3 times more than their earlier storage environment. As I said earlier, that when we are saying that we are talking about cloud agility, we are talking about how to make things simple, how to make technologies complementary in your environment. And that's what we have done at Valiant, right? What we have done is the customer continued with his existing storage environment. In this case, he had HP UX out there. We just put in a flash devices out there, right, where the hot data moved to the flash tier and gave him a 12x improvement in his performance. This is another case at Mercury Technology where we were able to reduce the batch processing times from 5 hours to 1 hour just by implementing a complementary device in their data center. I think the best example we can give you is about ourselves. This is what we did ourselves at IBM. We have total storage capacity of about 24 petabytes, out of which about 9 petabytes is on block I/O. About a year back, we took a massive consolidation exercise, used the same framework what we spoke about, and these are the benefits for you to see, right? We reduced our provisioning time from months to days. a 20% increase in storage utilization. But I think the best part of it was a 50% reduction in a cost per TB through effective tiering, right? And I think that's the single most important message which I would like to communicate out here. So just to go back to the main advantages which we see in the flash architecture is an 85% reduction, a 50% reduction in your software licenses, right? It not only optimizes your storage environment, it helps you also reduce your licenses cost and also reduce your server CPU count. 80% reduction in energy usage and microsecond responses, right? What I have for you, this is my last slide. This is something what I have picked up from my daughter's cartoon book. This is Winnie the Pooh, who is going down the steps, bump, 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 and wondering, is there a better way to go about it? And he wishes that he only had the time to think about it. So hopefully, me and my colleagues from IBM have given you enough time to think through and not go through bump, bump, bump in these 2 days. Thank you very much.